See, previous video we have seen about chiller calculation, how to calculate for air cooled chiller, right? Okay, and today we will talk about chiller's calculation for the water cooled chiller. Okay, if you talk about one of the schematic diagram, okay, you can see there is a chiller, right? This is the water cooled chiller where you have condenser, evaporator, expansion valve, and the compressor, right? Okay, remember last week we have seen that video. There are different type of compressors, okay, for the low capacity, for the medium capacity, and for the high capacity. Okay, and if you talk about water cooled chiller, majorly it is used for high capacity. Okay, so most of the time if you talk about water cooled chiller, it will be with the centrifugal chiller. Okay, because centrifugal chiller is capable of high capacity. Okay, uh, you can talk about like a 10,000 kilowatt or 12,000 kilowatt water cooled chiller. Okay, very large capacity. So that there only we'll be using the water cooled chiller where you have a smaller footprint, but you can cover with larger capacity. Okay, as an example, if you go with the air cooled chiller, the maximum capacity available, you can say like for the local region. Okay, you can go up to like 1500 kilowatt. Okay, say for example you have a project with the 15,000 kilowatt. Okay, assume like that. Okay, so then you have to go for 10 number of air cooled chiller, right? Plus maybe you have to go with the one number for the standby chiller. Okay, but in case if you go with the water cooled chiller, you can go with like a 6,500 capacity, 6,500 kilowatt or 7,000 kilowatt or 8,000 kilowatt. One chiller is available. Okay, so you can go with only simply two chiller plus one standby. You can go with three chiller instead of 16 chillers. Okay, so that is the difference if you go with the air cooled chiller and water cooled chiller. Okay, there are some advantage and disadvantage for both the condition, but you will save a lot of spaces when you go with the water cooled chiller. Okay, you can see the simple schematic diagram. Okay, you can see there is a building side. You have a building pump, then you have a evaporator side. Okay, then you have a chilled water piping connected to your load side, which is air handler unit or fan coil unit, whatever the units. Okay, so this is the evaporator side of the chiller. Okay, then when you talk about condenser side, you have a cooling tower, then you have a condenser water pump. Okay, so this is the condenser piping circuit. Clear, right? So you have a two circuit. If you talk about air cooled chiller, this particular condenser will be cooled by means of air. So you don't have any other circuit because this particular refrigerant will be cooled by means of atmospheric air. Okay, but here when you go to the higher capacity, you cannot cool that much capacity by means of air. So you have to rely on water. Okay, so that is why we are going with the water cooled chiller, right? Okay, so when you go with the condenser, this will be cooled by means of condenser water. Okay, the condenser water will be cooled by means of cooling tower. Okay, so today we will talk about the water cooled chiller selections, and then we will talk about cooling tower, how to select cooling tower, how to select the capacity, what is the water losses. Okay, how to select the makeup water pump, that and all we will see. Okay, now we will talk about in detail about the water cooled chiller selections. Okay, okay, if you go to this picture, you can able to understand how the water cooled chiller looks like, right? You can see that evaporator, then there is another cylinder is condenser. Okay, then you can see the motor. Okay, then you can see the compressor, you can see the central control panel, right? So this is the water cooled chiller look like. Okay, when you talk about air cooled chiller, that will be having a evaporator, then you have a V shaped condenser, right? Because that is cooled by means of air. Okay, so this is the water cooled condenser look like. Clear, right? Okay, now if you go to our calculation part, which we have seen last time, right? You have a total, how you are going to calculate the heating load by means of HAP calculation based on the outside condition, based on the room detail, lighting, equipment, people, then the envelope. You are going to calculate the total capacity of the project, right? Total, what is the project capacity or project load? Okay, how much load it is? Okay, assume that you have a total, say for example 2,400 kilowatt. Okay, the project load, say similar to as your air cooled chiller. Okay, or you can say that it is like 24,000. Okay, like when you talk about air cooled chiller, we are talking about very few thousands. Okay, but when you talk about water cooled chiller, you can talk about like a 10,000, 20,000, 30,000 like that. Okay, so that is the difference between water cooled chiller and air cooled chiller. Okay, so here as a same, you can talk about chiller capacity, the number of working chillers, number of assist chillers, the number of standby chillers, space constraint, right? So if you go with the air cooled chiller, you have to go with the 60 number of chiller. But if you go with the space to save the space, you can go with the water cooled chiller just to save the lot of spaces, right? Then you have a maintenance, then you have operation, okay, because you have condenser pump, then you have a cooling tower, so your maintenance cost will be increased and operation cost will be increased and your water usage will be increased. But whereas you can save lot of spaces, okay, then you have to calculate the water flow rate, then you have to calculate the COP for the chiller, for the compressor, chiller efficiency, okay, EER, energy efficiency ratio, then seasonal energy efficiency ratio, which is IPLV or NPLV, okay, based on ambient condition. Then you have a chilled water in and out, okay. Then if you talk about chilled, water cooled chiller, then you have a condenser water in and out, right? Then you have a condenser water in and out, okay. Then you have a refrigerant, type of the refrigerant, okay. Then there is a diversity factor. This one we have seen last week, right? Okay, the similar way also you are going to select the water cooled chiller as well, okay. You can see the one of the performance, okay. So this is the water cooled chiller look like, okay. I can see there are the performance sheets, right? So you can see that water cooled chiller performance sheets, right? Okay, based on the capacity, what capacity you are going to select, what is the type of refrigerant you are going to select the type of refrigerants, right? I think I have shared one of the video, what are the type of refrigerants and why you have to select, what is the purpose of refrigerant selection, right? What is ODP, what is GWP, okay, there are different type of refrigerants, okay. So you have to select low GWP and low ODP refrigerant to save the environmental, right? Okay, then you can see the capacity of the power, right? Then you can talk about performance like in the evaporator side, and you can talk about condenser water side, right? So this is the equation, okay. Say for example, you know the tonnage and also you know the chilled water temperatures, right? Okay, based on if you talk about any of the chiller, right? You can talk about like a 14.4 and 5.5 degrees Celsius for the chilled water side, building side. You have an inlet of like a 5.5 and out will be like a 14.4 from the load side, okay. And from the condenser side you can talk about 34, 42. So this is the general, this is a normal temperature, standard chilled water temperature and standard condenser water temperature. So based on that chiller is designed, clear, right? So now you have to calculate the flow rate. So if you could talk about the flow rate here, this is the equation. Remember we have seen some time back, this is the water side equation, how to calculate GPM evaporator, right? To calculate the GPM for evaporator side, tons multiplied by 24 divided by delta T. And if you want to calculate from the condenser side, tons multiplied by 30 by delta T. So tons we already calculated by means of HAB calculations for the entire project, okay. So if you want to calculate the GPM evaporator side, you can use this formula to calculate. Delta T, I have already explained you, the standard temperature difference, right? For the chilled water side and for the condenser water side. Clear, right? Okay. So based on that, you can able to calculate the evaporator side GPM and condenser water side GPM. So this particular GPM is purely required for to calculate the pump, chilled water pump. This is actually chilled water pump flow rate and this is the condenser water pump flow rate. Okay. So based on this flow rate, you can able to select your chilled water pumps. Okay, clear, right? Then if you go to this particular parameters, right, whatever I said, chiller capacity, okay, if my project 24,000, right, and if you go to the chiller, one of the chiller, okay, what is the capacity? You can talk about 1880 refrigerant ton. Okay, so if you talk about refrigerant ton, how many kilowatt? Basically, this will be 1880 multiplied by 3.56. So we are talking about 6,700 kilowatt chiller of one single chiller. Okay, so this particular chiller will be used for to cover 6,700 capacity. Clear, right, everyone? Okay, and if you go to our local regulations, remember we have seen for the water cooled chiller, what is the COP we have to achieve for T1 condition and what is the COP we have to achieve for T3 condition. Similarly, for the water cooled chiller also they have provided here. like for T1 condition, you can achieve 4.45. You can see the difference, right? Efficiency, right? So 2.8 nothing but what? Your cooling load in kilowatt divided by power. So if you divide, you can able to get to 2.8. Okay. So assume that 2800 kilowatt of chiller. Okay. The power consumption will be approximate 280, right? So 2800 divided by 100. Okay. So if you divide, you can able to see the COP, right? So you require 280 kilowatt of power to generate 2800 kilowatt of chiller. Okay, when you go with the air cooled chiller. Okay, but if you go with the water cooled chiller, okay, say for example, you can able to produce 445, like 4450 kilowatt of chiller can be generated in of 100 kilowatt power. Okay, so here 100 kilowatt power is required to generate 2800 kilowatt, but here the same 100 kilowatt you can able to generate 4450 kilowatt of cooling capacity. Okay, so that is the difference between air cooled chiller and water cooled chiller. So here there is a high efficiency. Clear, right? Okay. Now if you go to our calculations, right, like you can able to select the chiller capacity, and you can able to select the number of working chiller, depends upon the project. We have seen last week, number of assisted chiller, standby chiller, space constraint. Okay, now the COP of the chiller, right? The water flow rate, how you calculate? By using these equations. Okay, we have a heating equations. By using this equation, you can able to calculate the water flow rate for the chilled water pump and for the condenser water pump. Okay, the same flow rate will be if you calculate from your side, you will be getting closer to this value. Okay, but there is some lot of efficiency is concerned. So if you apply the efficiency, you can able to get the closer to that value. Okay, maybe not very exactly the same, maybe closer to that value, because there is efficiency matters, right? Okay. Now if you go to calculations, NPLV calculations or pot load calculations, right? Okay. You can able to see the formula, right, for NPLV or IPLV. Okay, what is the difference between IPLV and NPLV? When you calculate based on T1 condition, it is called IPLV because it is based on HRA condition, which is 35 degrees Celsius. If you do based on NPLV, non-standard pot load calculation, which is local regulation, the non-standard pot load may be local, like it may be UAE, or it may be Saudi Arabia, or it may be Qatar, or it may be any of the other country, right? Okay, like HRA condition is the where they have tested at say for example, if you talk about France, or if you talk about wherever the chiller manufacturer, okay, they do the testing at 35 degrees Celsius. That is based on HRA condition. So that value is called IPLV value. Okay, and when you do the testing at local condition, that is called NPLV value. Okay, to calculate the NPLV or IPLV, this is the formula we have seen last week: 0.01 divided by A plus 0.42 divided by B plus 0.45 divided by C plus 0.12 divided by D. Okay, so we understand that what is the reason, right? 100% of the chiller will be working only 1% of the entire period, right? And 42% of the entire period will be working 75%. 45% of the entire period will be working 50%, and 12% of the period will be working 25%. So that is why this value came across. Okay, so based on that value, you can able to calculate what is the NPLV or IPLV value. Okay, clear, right? Anyone have doubt regarding the water cooled chiller?